Hello, my name is Darren Thomas, and I am the Director of Educational Research Techniques. In this video, we're going to be taking a look at evaluating limits of functions algebraically, but this time with exponents and quotients. So let's go ahead and get started. All right, so we're going to start with the bottom rule here, and that is function raised to an exponent. And so basically, again, it's always hard to understand this abstractly. But if you read this mess here off to the right, it says the limit of x approaching a of f of x raised to the nth power. It's the same as the limit of x approaching infinity of f of x all raised to the nth power. That's kind of what's happening here. And so to make this as clear as possible and to help you out, we're just going to solve it so you can see what this particular rule is talking about here. So we're going to have the limit of x approaching -4 of 10x plus 36, all this raised to the third power. Now if we follow this rule here at the bottom, the function raised to an exponent, this is what this will look like. It's going to look like the following. We're going to have here everything in brackets, right? So, like so, the limit of x approaching -4 of 10x plus 36. All that's going to be in parentheses, and then right here, raised to the third power. So you can see basically what happened was that I took the exponent, this little guy right here, and I moved him completely outside the entire function. He's totally by himself now. He's kind of isolated. And so now all we do is basic substitution to get the answer. So we plug in -4. Sometimes my arrows are ugly there. Sorry about that. We plug in -4 every time where we see an x, and we get the following. We still have our brackets here. And now we have inside parentheses 10 times -4 like this, plus 36. Close out that. Raised to the third power like so. And then 10 times -4 is -40. So -40 plus 36 raised to the third power, and then -4 to the third power, because -40 plus 36 is -4, and then -4 raised to the third power is going to be -64. Just like that, you can see that we're done. And so this is our answer. So as x approaches -4, f of x, or the limit here will be approaching -64. That's kind of how that works out. So let's do the next one. Now we're going to be taking a look at our friend at the top here, quotient of functions. And if I had to read this mess to you off to the right, I would say the limit of x approaching a of f of x, or f of x over g of x equals the limit of x approaching a of f of x over the limit of x approaching a over g of x. That's what's happening there. And again, I'm sure that does not make a lot of sense when you just talk about it. Let's do an example. So we have here the limit of x approaching 7 of x squared minus 11x plus 28. All that over x minus 7. Close this out. So if we want to be really strict, because I don't want to skip steps here, because math teachers love to do that, we would have to write it out as follows. The limit of x approaching 7 of x squared minus 11x plus 28, all that over the limit of x approaching 7, make my little, there we go, of x minus 7, like that. Now the first thing we need to do in this particular example is we need to factor the top. That's what we need to do first. And so we will do that in a slightly different color so we don't get confused here. And so we're going to have the limit of x approaching 7 of x minus 7 and times the quantity of x plus 4, like that. All this over the limit of, the limit of x approaching 7 times x, or of x over 7. Now you can see that things are getting much simpler because now I have the ability to eliminate this right here. And so now I'm left with the limit of x plus 4. Oh, I forgot to write x approaching 7. And so what do we do? I think you remember. Now we just plug in 7 wherever there's x at. I'll change the color in case people are getting a little confused here. And so down here at the bottom, I would have 7. Is it minus 4? Oh my goodness, I made a mistake. It's minus 4 or is it no, it's minus 4. Minus 4. Oh dear. Okay, this should be minus. Sorry about that. This is minus 4 here, and this is minus 4 here. Sorry about that. It's x minus 7 times x minus 4, and over here we have x minus 4. So now it's 7 minus 4 equals 3. So as x approaches 7, the y value, if you will be approaching 3. So I'm sorry about that. So basically what happened was here is that when I factor it, I put a positive 4 instead of a negative 4. But when you work this out, you'll find that the quantity of x minus 7 times the quantity of x minus 4 will give you x squared minus 11x plus 28. I just made a mistake there. So please forgive me for that. And that is pretty much all we're going to do in this video. So let me just kind of review what we talked about and wrap up. So in this video, we talked about 2 additional tools for dealing with the function of limits algebraically. And that was the exponent rule, if you will, and the quotient of function rule. And so what the exponent rule is that when you have a particular function that has an exponent, you just kind of put it on the outside of everything. It's really not that complicated, and then you solve everything accordingly algebraically. For the function raised to an x, for the quotient of functions, it's really just a matter of splitting apart the numerator and the denominator. So they each become their own limit, if you will. And then in this particular example on this screen, we had to factor first, remove the common factor, if you will, which is x minus 7, and then solve for x using our x value in the limit. That's all we did. Not that complicated. Again, it's just an extension of many of the tools we've learned in the past. So I just want to thank you for watching. My name is Darren Thomas. I am the Director of Educational Research Techniques. Take care.